So now it falls to us to solve this inequality. Is a quadratic inequality, not a linear inequality. Any polynomial inequality that's not linear requires us to use either graphing method or sign chart method. So I'm just going to demo both right now. So graphing method is we just sketch a graph of it. So of course the challenge is you need to know graphs well to do this, but you need to know graphs well anyway. You should be able to look at r of delta t equals 1.17 delta t squared minus 10 and be able to graph that easily and quickly, because you know that this is a quadratic equation. It's a parabola. It's facing up because the leading coefficient is positive. Negative 10 is, you can do this by transformations. We have delta t squared as your fundamental parabola, multiplied by 1.17. That's a vertical expansion, and then drop at 10. This minus 10 is a vertical translation. You should know all that stuff. All right, so basically what you have is a parabola. It looks like this. Doesn't have any holes in it or anything weird. So all we need to know is where are the x-intercepts. So I can find these x-intercepts symmetrical, so I only really need to find one of them by going 1.17 delta t squared minus 10 equals 0. So it's pretty obvious that delta t equals the square root of 10 over 1.17. That's the x-intercept, all right? But the solution of the equation is not just delta t is less than this number. By the way, I did this number on my calculator beforehand, but then I deleted it. So let's just get a decimal for it. So we can go square root of, and then we'll do fraction-y thingy, because that's fun to do. And we'll do 10 over 1.17. And we get 2.9235. So let's 2.9235. So rounded it off. All right, so that means that the other one, because this parabola is symmetric about the origin, it's an even function, right? That means the other delta t intercept is also negative 2.9235. So in fact, the solution to the inequality is not just delta t. The solution to this inequality is not delta t is less than 2.9235. It's delta t is an element of the interval from negative 2.9235 to positive 2.9235. And of course, I've rounded that off, so it's really square root 10 over 1.7 on both sides. Okay, so that's graphing method. So the other way that people do this is they do it by sign charts. So this is graphing method. The other thing that people do is a sign chart. So to do a sign chart, you do a number line, and then you still find the solutions to this equation. So you find the solutions to the associated equation, 1.17 delta t squared minus 10 equals 0. You still have to do that either way. So you're still going to get the same solution. Delta t is square root 10 over 1.17, so it's approximately equal to 2.9235, but plus or minus. Right? As you're going to solve that, you're going to do plus or minus when you do square root of both sides. All right, so here's 0 right here. Here's our actual intervals that we're checking the signs on. Negative 2.9235, positive 2.9235. These two x-intercepts divide the real line into 3 distinct intervals. So now all I need to do is check the sign in each interval. Check the sign of this expression in each interval. Check the sign of this. Right? So the easy one to check is the one in the middle. So when we have delta t equals 0, we're going to have, you can pick any number. I could use negative 1 to plug into the original equation. So we pick any one value is going to have the same sign throughout the interval. So if I pick delta t equals 0, that's just easy because I get negative 10. So negative 10 is negative. So some people will like, okay, it's negative all through this interval. So they'll indicate that like that. Then they'll say, okay, now I need to test a number from this interval over here. So an obvious number to pick to test this interval would be 3. And you could do that and you could plug in here and see if you get a positive or negative. I like to simplify my work. So the value I'm going to pick for this interval is 10 million. It's going to make it much easier. Because look, if I do 1.17 times 10 million squared and I subtract 10, I will obviously get a positive number. So that saves me the work. So actually by choosing a huge number, that saves me the work of working out what 1.17 times 3 squared minus 10 is. Right, so I know this whole interval is positive. Any one value in each interval determines the sign of the entire interval. That really comes from the graph. All right, so now we want to check this interval over here. So I'm going to do the same thing. Instead, I could pick -3 as my representative number, but I'm going to pick -10 million. -10 million squared is going to be a positive, so I'm going to have a huge positive number minus 10. It's still going to be positive, so I have positives over here. So now what I do is, since my inequality is less than 0, I'm going to look for the interval where the signs are negative. That's this interval. Just like on this graph, and I'm not sure I mentioned it, by the way, the way we get the interval is when we're looking at the inequality, it says, where is this expression less than 0? That tells me I'm looking for where is the graph below the x-axis, and that is on this open interval between this number and this number. So either way, we get this interval as a solution to the inequality. So the inequality this inequality by itself does not give us just delta t less than 2.9235. It gives us delta t as an element of the interval from negative 2.9235 to positive 2.9235. In this case, that turns out not to matter. However, in general, it is going to matter, so make sure you know how to solve a polynomial inequality.